Hi everyone, my name is Julianne Albion and today is July 16th, 2020 and we'll be doing Advanced Interactive Concept Module 8, I can't believe it's already 8, which is the instant ice. So after watching that water bending video, I took my water bottle and got that prepared. So I have a frozen water bottle here and then just a little bit of ice. I'm just going to be a little bit careful with this because, it's going to change around a little bit, which is really cool to think about. So basically, we just need the water bottle. To freeze it. I'm going to tell you about how long I froze it for. Then I just put a cup of ice in here. So for that sake of the experiment, I did pre-freeze my water bottle. So now the original video that was linked said to do about 2 hours and 45 minutes. But I did half of that, which was about just a little over an hour and 22 minutes, plus a little bit more, only because the original video that was showing how to freeze the water at an appropriate level was 16.9 ounces of water, and this one is just an 8-ounce water. But it's not open. It's never been open. It's a Poland Spring bottle, so it's extremely purified. So that's why it was a little bit more than double. So I do wonder if the size of the bottle has an effect on how solidified the water became. So that's why I tried to figure out the proportion properly. So then I just did half of the amount of time that was told, and then just add a few more minutes to that. So it should be liquid and cool down and to the temperature that's well below freezing. So as you can see, a little bit inside of it is frozen, but it's still not completely frozen. It's to the point where it's still liquidy. So I'm going to be attempting to crystallize the water above the ice cubes. So I should be able to have a little ice sculpture as shown. But before that, if I were to poke a hole into this bottle, it should be able to immediately freeze up and freeze up the whole bottle along the whole way. Or if I sharply knocked into the bottle, it's the bottle of super cold liquid onto the table, it should instantly turn into slush before your eyes, which actually happened when I took it out of the freezer because I kind of banged it into it and then it started to freeze up a little bit. But I'm scared a little bit because I want to kind of do this already because it is starting to cool down a little bit. Warm up a little bit because it is a little bit hotter in my house right now because it is summer. Yeah, so I'm going to try it out, test it out, and see. Hopefully not a lot comes out because I know as soon as I open it, some water may come out. A little bit scared because this is icy. So it didn't work. It just kind of went around here. I guess maybe it was a little bit not slushy enough. So maybe that just means that it wasn't frozen enough. I did try to do my calculations. It is really cold. It is just melting it just a little bit. But so this water should have froze immediately. I think that just means that maybe you can't do this experiment with a smaller type of bottle. Maybe that means that you have to be able to do it, that you should be able to do it with that 16.9 ounce bottle of water. But also they did have a different brand of water, but this is a purified type of water. So I'm really not too sure. Honestly, I think maybe it might have not been frozen too much. But I did do it according to the calculations, because I assumed that just because it was a little bit smaller, it would change the amount. So basically, when water is freezing, the molecules that come together in a very very organized way, it should form a crystallized structure. So, which is really disappointing because I really wanted it to go up like it should have. But I could tell you that as soon as I banged it, when I wasn't in here in front of the camera, when I came outside of the refrigerator, of the freezer, it did start to go up a little bit. I saw the freezing go up. Didn't catch that on camera though. So basically, because of the crystalline structure, water molecules have ice that as ice have less energy and the water molecules as a liquid, which means that in order to go from a liquid to water to a solid water, the molecules have to lose that heat energy. So in other words, because the water freezes, when you tap it or open it, it warms up the rest of that water. So basically the heating may allow that small percentage of water to freeze, which would allow for that slush to kind of form in the bottle instead of being a solid, instead of being a whole hard chunk that you would get a big chunk of a block of ice kind of. So those ice crystals that form happen really, really quickly. They would usually form along the whole thing. So I really do think maybe it was just not quick enough. Didn't do it right away, maybe. Also, that could be like another problem. Like, you have to do it right away. Like, I took it out, I got my ice, and then I did it. Maybe I should have had the table ready and then put the ice in. So basically, when water is cooled to its freezing point, then the ice crystals can begin to collect in the water. Snowflakes, for example, they're crystals that sometimes they grow and they have imperfections on there. So depending on the water, the locations on the bottle, depending on where that is, that could be more frozen. If it's a really good purified water and it cooled, it could only really form that liquid, which is really what happens. So that's probably why. So maybe it was some kind of impurity in it. Otherwise it should have been sped up and the crystallization should have occurred even more. But I wonder if you could do this with soda. Like, I should have had like my soda bottle next to it. But I really don't think it might, actually, because like the whole reason this is happening, the crystallization, is because the water is so completely pure. It's never been opened before. As you saw, I saw water coming out, and sometimes it can even spurt out. But I'm thinking maybe not, because the solutes that are added into that liquid, such as like the color, the sugars that have been added inside sodas, they may have an effect towards freezing it. So maybe it wouldn't actually be able to freeze and crystallize the exact same way, because sometimes soda has to reach a much colder temperature than plain water and purified water would have. This is really cool. I wish I showed you guys that I was a waterbender, but that's okay. I guess I had better luck with that fire from last few experiments ago. So I guess I'll just call myself a firebender instead of a waterbender. Yeah, I hope you guys enjoyed.